Hey everyone, and welcome to this Engineering Enablement Explainer. Today, we're going to completely transform how you view, structure, and customize GitHub Copilot across your entire enterprise architecture. If you've been relying on personal configurations, or maybe just wondering why your AI assistant acts completely differently than your teammates, well, you are absolutely in the right place. We're going to break down exactly how to standardize your Copilot environment for maximum efficiency.
So, here's our roadmap for today. We'll be covering the need for governance, the customization landscape, the file decision tree, repository instructions, IDE support matrices, and finally, the enterprise roadmap. Let's jump right in.
Section 1. The need for governance and scaling Copilots.
Right now, a lot of developers just configure Copilot to their own personal preferences, and the result? It's a chaotic mix of overlapping instructions. Honestly, it's kind of like the AI equivalent of the tabs versus spaces war. One developer's setup fights another's, the repository context gets completely muddled, and the outputs become incredibly frustrating and unpredictable. Without a common standard, maintenance literally becomes a nightmare.
So the absolutely crucial point here is that Copilot governance isn't actually about restriction at all. It's about context efficiency. It's the practice of always using the narrowest, most specific tool for the job. You definitely don't want to load a massive set of global rules just to solve a tiny, localized problem. We really need precision here.
Moving on to Section 2, the customization landscape and the Copilot ecosystem.
We're looking at an entire macro ecosystem right now. It branches from really broad instructions that dictate how to work, all the way down to highly specialized agents and skills that tap into external capabilities. Let's break these down one by one so it makes perfect sense.
Starting with the absolute basics, instructions are your foundational rules. They basically sit in the background and tell Copilot exactly how it should operate within your specific project scope. Think of them as this persistent work this way mandate, like always enforcing a specific architectural pattern or security standard across your entire codebase.
Prompts, on the other hand, are highly intentional. These are reusable, task-specific requests that you, the developer, actually trigger. Instead of a background rule running constantly, this is you actively saying, do this task right now. Like, for example, telling Copilot to generate unit tests for a specific function, or asking it to review a block of code for performance.
Now, skills step things up a notch. Instead of bloating your global instructions with, say, a massive 500-line API procedure, you create a skill. Copilot only references this capability when you're actually building an API. It's all about progressive disclosure, keeping your context window incredibly lean and efficient. And finally, we have agents. These allow you to define specialized AI personas. Imagine having a dedicated architecture reviewer agent with its own specific constraints. Or maybe a read-only agent that's only allowed to search and read but absolutely cannot modify code. Agents take the command act as this role and give Copilot a highly tailored identity and toolset.
Section 3. The file decision tree and choosing your customizations.
Okay, so this is where the rubber meets the road. When you have a requirement and actually need to customize a behavior, which Markdown file should you use? Is it a prompt file, an agent file, global instructions? Making the wrong choice here leads directly to that bloated context we're desperately trying to avoid.
Think about this as a very strict engineering flow. Ask yourself, does the rule apply to almost every single task? If yes, then use the global Copilot instructions.md file. But what if it requires an external system, like Jira? Well, then you'd use the Model Context Protocol, or MCP, to bridge that gap. Following a logical tree like this guarantees you're always applying the narrowest mechanism possible.
Let's hit Section 4. Repository instructions and structuring for scale.
A massive, massive trap developers fall into is assuming that just because Copilot discovers a file, it automatically activates it based on some universal numeric order. Like, oh, this file is parsed last, so obviously it wins. Actually, scratch that, it doesn't work that way. That is a completely unsupported assumption. Discovery absolutely does not mean activation, and precedents can vary wildly.
You really have to avoid conflict by moving away from generic global rules. For example, if you tell your global Copilot instructions file to always use NUnit, but your actual testing directory specifically needs XUnit, you've got a direct conflict. The solution? Use path-specific instructions via the apply to property. That way Copilot only uses XUnit when it's actively looking at the testing folder. Problem solved.
So, if we summarize the golden rule of structure, never, ever overload your global instructions. It just completely wastes context. You want to keep the foundation incredibly simple. Write short, global instructions, and rely on detailed skills or path-specific rules that are loaded only when they're actually needed. Keep it simple, keep it targeted.
Section 5. IDEs support matrices, comparing Copilot tools.
When we compare these tools side by side, it instantly debunks the myth of complete feature parity across all IDEs. Seriously, what works seamlessly in VS Code right now might only be in preview for JetBrains, or it could be completely unsupported in Eclipse. Even GitHub.com has its own distinct way of handling instructions versus cloud agents.
Now, why does this matter to us? Because your core engineering standards should never depend on a single IDE's exclusive features. For instance, custom agents currently require specific newer versions of Visual Studio. You simply cannot mandate a company-wide workflow built on custom agents if half your development team is using JetBrains or Eclipse and literally can't access them yet. You have to design your governance around what your whole team can actually use.
Finally, Section 6, the Enterprise Roadmap for rolling out Copilot.
The fundamental mindset shift we need to make is this. Copilot customization is engineering configuration. It is code, and that means it requires the exact same rigor as your production source code. You absolutely need clear ownership, mandatory pull requests for any changes to instruction files, strict version control, and real metrics tracking to see if your context efficiency is actually improving.
We're going to roll this out systematically. Step 1, establish a lean, standardized global foundation. Step 2, introduce targeted, path-specific rules only where they are strictly necessary. And Step 3, start with the absolute smallest amount of customization that consistently improves Copilot's output. Don't over-engineer it right out of the gate.
I want to leave you with this final, really vital thought. True scale requires standardizing our AI just as tightly as we standardize our code. If you let Copilot remain a wild west of personal experimentation, you are never going to unlock its true enterprise value. So, the question is, which path is your team going to choose? Thanks for joining me on this explainer, and I'll see you next time.